Hey everyone, welcome to APC Mastery Path. This is Mo, and today we're going to be diving into an exciting topic of how to fine-tune your large language model using Unsloth on your own data. If you are new here, do not forget to hit that subscribe button and ring the bell for notifications so you never miss out on our latest tech tutorials and insights. In this video, I'm going to be guiding you through each step of the process, from setting up your environment, importing datasets, fine-tuning the model, to deploying it locally using Open WebUI. By the end of this video, you will have your own custom language model ready to go. Make sure to check out previous videos if you haven't already, and I'll put all the links in the description below. So grab yourself a cup of coffee, get comfortable, and let's get started on this journey to mastering model fine-tuning with Unsloth. Unsloth is an initiative on GitHub which allows for the parameter-efficient fine-tuning of a wide variety of the models, including Llama, Mistral, Phi, and Quinn. And it also makes the best use of the existing infrastructure, which means that you can use your computational power to the max. This expedites the process of developing prototypes and even make working commercial products. We're going to be discussing this section of the video, how you can install Unsloth on your machine, how you can deal with the dataset or the datasets that you're going to be uploading, what formats you have to follow, and also we're going to be manipulating a little bit the training arguments to suit our needs. And finally, we're going to be training and saving the model locally and through the Hugging Face website. Having explored the overview of Unsloth, it's now time to explore what packages and what piece of software needs to be installed in place before we dig deeper into that new approach. So the first thing is we need to have Windows Subsystem for Linux installed on our machine. Unfortunately, Unsloth, it does not support Windows. It just runs on Linux or Windows Subsystem for Linux. So the way to do it is you can go to the website of Microsoft to understand how to install Windows Subsystem for Linux, or simply you go to your PowerShell and you can write WSL -- install, and then it's going to install Windows Subsystem for Linux 2, and I think Ubuntu is going to be downloaded and installed on your machine. It's going to take a little bit of time to download it and install it, so bear that in mind. You can also go to the Microsoft Store and you can search up top for Ubuntu, and then you can find it free to use. I have an older version, a little bit of an older version. That is a newer version that you can install on your machine. I have installed it already some time ago. And then you also need to have Anaconda installed. So the way to do that is you can go to the Anaconda main website and request Anaconda to be sent to you on your email. Or I've already provided one of the versions for Anaconda, so you can download that and on a specific folder. And then if you want to open Windows Subsystem for Linux on your machine, there is a graphical user interface. So if you open My Computer, and then you'll find that there's something called Linux here to the left of your screen. You can go to Ubuntu, and then you'll find a wide variety of them folders. You can create your own folder anywhere you want. For me, I used home and then the name of my user, and then I created a folder called projects where I'm going to be building a number of them projects. So create a specific folder for you and then save Anaconda in here, because we're going to be using that later. And then you can open a terminal in that specific location. And then you need to open that specific folder so that you can open the terminal in this specific folder. So when you have VS Code, if you go to extensions, there is an extension called WSL. You search for it and then install it. That allows you to open Windows Subsystem for Linux on VS Code. On the bottom left, you will find these two arrows. If you click on one of them, you will find that there's an option called Connect to Windows Subsystem for Linux using distro. If you click on that one, you can click on Ubuntu. Having reached that point, you can then go to File and then Open Folder. You can choose the folder that you have created and then press OK. So as you can see on the left, that is the folder that I have created, and I'm going to be dumping in some data in here and the likes. Reaching that point in time, you can click on Terminal and then New Terminal. You'll find it here at the bottom. In order to make it easy for the eye, you can move Terminal into the editor area, and then you can click on that one and slide it to the right so that you can have your own coding environment here and you have your own terminal on the right. So you can copy and paste these two lines of code, but make sure to change the word version to that one, 2024.02, here and here, instead of the version and the square brackets. The next step is going to be installing Unsloth locally on your machine. So to make it easy for the eye, I have already put in here the lines of code that you can copy and paste in here. So basically, you're creating an environment or a virtual environment called Unsloth with Python version 0.10 and some dependencies installed, such as CUDA, NVIDIA CUDA Toolkit and PyTorch with CUDA enabled. And then you're activating the virtual environment. You're installing everything from that repository of Unsloth, and then lastly, you're installing some bits and pieces, such as the transformer, reinforced learning package, weights and biases, Hugging Face Hub, parameter efficient fine tuning, accelerate bits and bytes and datasets. I have found that there are some issues when some errors and some issues when I did that just by following the Unsloth steps on the Unsloth repository in GitHub. So I had to download and install PyTorch from the original website of py.org. So I've already included here the code from PyTorch websites for PyTorch with CUDA enabled version 12.1. And also I found out that I need to have NVIDIA CUDA Toolkit installed, or as they call it, NVCC or NVIDIA CUDA Compiler. You can go to the NVIDIA website and choose your own specific version. I've chosen 12.1 and I've included all the code for it for NVIDIA website. Taking into account the installation of Unsloth on your machine, now it's time to write some code. So in the folder that you have opened, open VS Code and make sure that you have created a file with whatever name that you please, and then it's going to be .ipynb. And it's going to ask you for two things. First one is to install the IPY kernel to be supported with the current Python environment, and also try to set the kernel to the current created virtual environment so that you don't have any conflicts. We're going to be importing PyTorch or Torch. We're going to be also importing the training arguments from the transformers. We're going to be importing the datasets or the load dataset from the datasets library, because that's going to allow us to import different datasets however we please. Setting out the maximum sequence length to 2048. That's going to define what is the maximum allowed length of the input to your model. Unsloth, they allow the rotary position embeddings scaling, which is one of the mechanisms to deal with variable lengths of prompts, and that's going to allow more efficient prompting and inference process in total. We'll also have to import the Unsloth library or package that we have already installed from the GitHub repository of Unsloth, and also two things, which is basically fast language model and the floating point 16 for the accuracy and precision of the model. The next step will typically be importing the datasets or the datasets, and then we're going to have to do some transformation and cleansing for the data to make it ready to be used by the model in the fine-tuning process. So the dataset that I do possess is a very simplistic CSV file where I have crafted manually the questions and answers. So what is going to be the question and what is going to be the answer. It's a very simplistic data set where I have crafted manually lots of them answers and lots of them questions, and made use of some older documents that I do possess. So in our code, what I have done simplistically is that I have identified the path of the file itself and used the load dataset function to upload that CSV file. And then I did some tweaking because the models in the fine-tuning process, they rely on JSON format, and I'm not quite familiar with JSON format. So the models rely on the word text, or a title text, and then human, and then a specific question, and then bot, and then a specific answer. That is the format that is required in the fine-tuning process, as you can see here. So a text, and then human, and then text, and then a bot, and then text. I managed to do that, and then I deleted any other columns that I'm not going to be using in the dataset. And in order to make things visible for me, I created a number of them functions, but these are not required. It's just for myself to be able to visualize the data in a much easier way. So it's basically here I'm extracting all the text between human and bot, which is basically the question, and here I'm extracting all the text after bot until the end of the phrase or the text itself, which is the answer. And then I printed here the merged or the transformed datasets, and then the question only, and then the answer only. And then, as you can see here, the sixth entry is give me a good quality example of competency, blah, 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 level 1. And then the answer is whatever it is. And the lines beneath it is just basically the question separated from the answer. That is just for visualization purposes. These functions, they are not required at all in the code. Having installed the requirements for the Unsloth environment, importing the necessary packages, the datasets as well, it's now time to import one of the models provided by the Unsloth team. So if you click on this link that I'm providing within this Jupyter Notebook, you will be able to find all of the models that are provided by the Unsloth team. It's about 84 models. Some of them are instruct, some of them are base models. So you can search by the word instruct. And then you can find a plethora of the models, as you can see here. Some of them are Quinn, some of them are Phi, some of them are Llama with different variations of Llama. Some of them are Mistral. And the instruct models, they are quite useful in our case scenario, because we're going to be providing give me something or do something, and the model is going to be doing something or giving me a specific answer. So the instruct models are very good when it comes to giving specific instructions or giving specific orders or demands to a model. So I'm using the first language model library from the Unsloth Main library, and I'm importing the Mistral 7 billion parameter model instruct version 0.3. You can change this according to your liking. The maximum sequence length was defined to be 2048 in the beginning of our code, which is the length of the input to the model itself. And as you can see here, there is also one thing which is quite interesting from Unsloth, which is allowing to load the model in 4-bit in order to be used on consumer grade GPUs. And when I ran this code, I was greeted with some sort of very interesting views about the current infrastructure that I do possess, which is basically my laptop, taking into account the CUDA version, the CUDA toolkit version, what GPU I do possess, and the likes. The next step, it's optional, it's not mandatory for the model fine-tuning. It's basically to compare and contrast between the non-fine-tuned and the fine-tuned model. when it comes to text generation. So in order to do that, I have created this function which takes an input, tokenizes the input and encodes it, and then produces the output, or decodes the input into an output and then prints the decoded output. And I've given the model, the unfine-tuned or the non-fine-tuned model, a very simplistic question, which has helped me draft a good example of procurement and tendering level 2. And it gave a very faffy answer. It's a very loose answer, which is quite understandable because the model doesn't really understand what I want, and that's the whole purpose of this task. Nowadays, when you're trying to do the fine-tuning of a large language model, it's quite evident that we need to use low-rank adaptation method for that fine-tuning process. So in this section of the code, we are trying to define the modules that we're going to be targeting for the LoRa method, the ranks, the higher the rank factor, the more computational power required, and the more accuracy that is going to be achieved, and vice versa. Also, the Unsloth method, it uses gradient checkpointing, which saves memory during training, and it has two values, true or unsloth. So true is for longer length context, and unsloth for the shorter ones. And then there is a maximum sequence length that we have already defined before. Also, the Unsloth method, it makes the best use of the rank stabilized low rank adaptation and also the lower frequency training quantization. And these two methods, they aim at increasing the efficiency of the fine tuning and make the best use of the available computational power, and use less video memory as much as possible. So reaching that point, we have already invested a lot of time in crafting our code and putting in some decent parameters. And now it's time to initiate the training itself. But before we do that, we need to get the training arguments in place. Unsloth, they do use Weights and Biases website to track the training process itself and provide very thorough feedback. And it's a must. So you'll have to install the Weights and Biases packages as explained above, and you need to go to wandb.ai, which is Weights and Biases.ai, create an account, and you'll have to have a key which you're going to be copying here. So weightsandbiases.login and then your key, and this allows you to avoid any sort of errors in your code. The next step would be having the supervised trainer to be deployed in the code itself, where you're going to have to specify some arguments and parameters. So the first one is defining what model, which is the one that we have imported above. We're going to be using the training dataset that we have converted above and loaded into the system. We're going to be using the text identifier, which is the main key in our data. You can change that to whatever you want, but you have to be uniform in your code. So if you change that one here to, for argument's sake, data or question or whatever it is, I'll have to do that in the step of importing the dataset. The maximum sequence length, that's the 2048, which has been defined at the beginning of the model. The tokenizer is the same as the model itself, so it's taking the tokenizer from Mistral version 0.3. There are some training arguments that we need also to keep in mind, such as the warm-up steps. You can picture the model as a person who's running in a track, so it has to do a warm-up. So it's going to take the first 10 steps for a warm-up, and then the training steps. I would advise that you have to have more than 1,000 steps if you're going to be doing something to be used for commercial purposes. For me, I was just aiming for a prototype, like a high accuracy prototype. That's why I limited it to 500 steps. The Unsloth team, they are already trying to safeguard ourselves from having any errors in the code by using two different methods to make sure that the floating point 16 precision is used. The logging steps, that's going to be completely up to the end user to choose how many logs need to be saved in order to understand the metrics. All of the configuration that you have done, that has to be saved somewhere. So that is the directory where you're going to be saving your model checkpoints and configuration and log files. You can name it however you please. I just called it outputs. And then the Adam optimizer, which is nowadays the main optimizer used in the fine-tuning industry, and it's optimized for 8-bit precision. The next part of the code is basically training, and in training it's going to take you a little bit of time. I've done the 500 steps, and it took me, as you could see on the screen, 38 minutes and 37 seconds. And again, that is on a laptop, so that's not a lot of time. I do possess 16 gigabytes of graphics memory, but it's a mobile graphics card, so definitely it's not the strongest. And as you can see here, you would find the steps and the training glosses. The training glosses, they started from 3.26 and they decreased up until 0.14 or 15, as you can see here, 0.15. The last steps of the model is saving the model locally and on the Hugging Face website. Before you do that, you can optionally test the trained model to see where you're sat and if the training is well or not. In my case, based on my experience, the training was good, and I will show you how I tested it on the Open WebUI chatbot front end. In the testing part, it's basically making use of the previously generated or the previously crafted function, which is generate text, giving the model a question and expecting an answer. I will show you that in a bit on Open WebUI. And then the last step is basically saving the model on your computer or on your means of storage, and on the Hugging Face website. I prefer to keep copies because I can use it without relying solely on the Hugging Face website. So you can save the LoRa adapters only by model.save underscore pre-trained, and then if you want to save the model plus the LoRa adapters, which is basically the fine-tuned model, you can save it in this method by model.save underscore pre-trained underscore merged, and then the accuracy that your model is going to have is 16-bit accuracy. And lastly, on the Hugging Face website, you can upload your model or push the model to the hub by making sure that you have an access token, and you are defining the directory where you want the model to be sat, and the directory where you want the LoRa to be sat as well, if you wish. For me, I pushed both the LoRa and the model, the merged model or the final fine-tuned model to the hub, which is using push to hub and push to hub merged. Make sure that you have the token as well in place in both sides of the code. And here, as you can see, there's LoRa, which is saving the adapters only, and here, which is saving the merged model. Having fine-tuned your model and pushed it to the hub, which is an optional thing to do, you can go onto your own account and then click onto your own account. You will be greeted with all the models that you have done so far, or the model that you have done. So that is the one that we have recently done in this code. If you click on it, you will find lots of bits and pieces that have been already crafted and drafted by the Unsloth team in their underlying code. If you go to files and versions, you will find that you have a number of safe tensor files, and these are the main backbone of the code itself. You'll find also the tokenizer, you will find different bits and pieces, the configuration file, and the likes. So this format, unfortunately, it's not read by chatbots, so you would need to have some sort of like a GGUF format. So there's a way to do it which is super easy. The Hugging Face website, there is a team, they have created a repository called GGUF My Repository. If you search in Google, the first result, which is GGUF My Repo, Hugging Face space by ggml-org. It's completely for free. If you click on it and then you log in using your username here, you can search with the model ID on the Hugging Face website. So if you go back to your model, you copy that link, and then you go to GGUF My Repo, and then you paste it here. If you have not made your repository private, if it is public, it's going to be apparent here. And then you can click on it, and then you can be choosing the accuracy that you want. In my case, I prefer the 8-bit quantization, and then you can click on submit. It's going to take about 3 to 5 minutes depending on the load on the machines. If you see up above, the video memory is A10G, which is quite close to an RTX 3090. There's a difference of about 8 to 10% in the performance between these two. And as you can see here, there is 24 gigs of video memory that is available for you, which is a bonus. And then it's going to create for you another repository with the quantized model. So if I go here, and if I go back to my main repository, there is one which they have created for me, and they have called it already dash Q8 underscore 0 dash GGUF. And GGUF is basically a GPT generated unified format. If you go to files and versions, you would find that there's a 1 GGUF file. If you click on the download, you can download this file to machine, and then we're going to be using it within the Open WebUI system. And now it's time to deploy the fine-tuned large language model into the Open WebUI environment. I've already created a video which I'm going to be putting the link in the description below about how you can establish your own Open WebUI environment on your local machine. There are some requirements that we need. The first one is Docker, which allows running containers of codes separate from one another on your machine. You can download Docker from docker.com/products/docker-desktop/, and then you can download it for Windows, Linux, or Apple Mac. Also, you would need Ulama, which you can download from ulama.com/download, which allows using large language models locally on your machine. Also, you would need the Open WebUI installed in your machine. So once you have installed Docker and Ulama, you can then go to their GitHub repository, which is github.com/open-webui/open-webui. And then if you scroll down, there is installation with default configuration. In my case, I do possess a graphics processing unit, so I used that third line of code, which is running with NVIDIA GPU support. You can copy that line of code and then open command prompt window, and then you can copy it and paste it here. As a piece of advice, you can name it here into GPU so that in the future, if you want to create other containers within Docker, they're not conflicting with one another. And when you press enter, it's going to take some decent amount of time because it's going to download about 3 gigabytes of bits and pieces. Once that's finished, you can easily open Docker, and it will create for you one of them environments. I have already initiated the environment itself, or the container, and it will create for you a local host link, which you can click on. I've already clicked on it, and it's that one here. So the Open WebUI environment on your local machine, whether it's a desktop or a laptop. I've created a separate video about Open WebUI, so I'm not going to be digging deeper into Open WebUI for now, but I'm going to be showing you how you can upload some models. So if you click on your name here and then settings, you can go to models, and then you can write whatever models you want from Ulama, or what we want is having a GGUF file uploaded to Open WebUI. So if you scroll down a bit and go to experimental, and then go to show, you will see that there is upload a GGUF model. You can click here to select, and then select the downloaded quantized model, and then open, and then upload. Once that's done, you can open a new chat, and then you can select your model from here. I've done that already, and I've asked the model, I'm an RICS candidate, give me a good quality example for contract practice level 2. It gave me a very thorough answer, and I see this as quite advantageous because I can pick whatever I want from this, and it basically gave me all of the examples with good quality. It mixed a little bit between level 1 and level 2, but definitely a person who's crafting their own file, they would be understandable of this matter, and definitely it's going to be much more accurate if I used a large language model or a larger data set. You can think about bidding, you can think about CVs. There are lots of other initiatives that can be undertaken in the same manner. You have a data set that you do your cleansing on, and then you import one of the models from Unsloth, might be the larger ones, such as the Llama 70 billion parameter model. You do the fine tuning, and then you import it within Open WebUI. Thank you so much for watching. I hope you found this tutorial helpful and that you're excited to start fine-tuning your own large language models. If you enjoyed this video, please give it a thumbs up, subscribe to APC Mastery Path, and share it with your friends. You can also follow us on LinkedIn for the latest updates and exclusive content.